Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this review of quadratic equations. So why do we need to do this again? Well, what we're going to do is we're going to graph parabolas, and their graphs always look something like this. So the solutions to a quadratic equation are these two values here, where the parabola hits the x-axis. They are the x-intercepts. Of course, a parabola can have two x-intercepts if it looks like that. It can have no x-intercepts. It can have one x-intercept if it looks like that. So it's important we know how to solve quadratic equations in order that we can graph parabolas. So quadratic equations are equations of this form: ax squared plus bx plus c equals 0. The x squared makes them a quadratic equation. We don't treat these like linear equations though. We have two ways to solve quadratic equations. We can either factorize, that's one method, or use the quadratic formula, that's the other method. Remember, if we're factorizing, we factorize binomials and trinomials differently. So let's look at binomials. So that's when the quadratic has two terms. One term, two terms. So there are two methods: difference of two squares or highest common factor. So remember, if we're going to factorize difference of two squares, we get two brackets. We square root the first. We square root the second. And then one bracket gets a plus, one gets a minus. So after factorizing, we use the null factor law. Either the first bracket equals 0 or the second thing equals 0. So if the first bracket equals 0, we get x equals minus 5. If the second bracket equals 0, x equals positive 5. So they are the two solutions to this equation here. So when I go to graph this, it will have two x-intercepts at minus 5 and 5. So this second one here is also difference of two squares, because I have a perfect square minus a perfect square. I can't use highest common factor. This term and this term have no common factor. So using difference of two squares, I square root the first, so the square root of 4x squared is 2x. And then I square root the second. One gets a plus and one gets a minus. So either the first bracket is equal to 0. So if 2x plus 3 equals 0, subtract 3 divided by 2, I get x equals minus 3 over 2. If the second bracket equals 0, then x equals positive 3 over 2. So they're the two solutions. So for these last two, I'm going to use highest common factor because there is a common factor. This term and this term have a highest common factor of 3, and there's also an x in both terms. So I write the highest common factor out the front. What do I times by 3x to get 3x squared is x. What do I times by 3x to get 6x? And that's 2. So either the first thing equals 0, if 3x equals 0, x equals 0. Or the second equals 0, which would mean x is minus 2. Once again, if I were to graph this, y equals 3x squared plus 6x, there'd be two x-intercepts, one at 0, one at minus 2. So this one here is also highest common factor. The highest common factor is again 3x. So what do I times by 3x to get 6x squared is 2x. And what do I times by 3x to get negative 15x is minus 5. So either the first thing is equal to 0 or the second thing is equal to 0. So if 2x minus 5 equals 0, add 5 to both sides and divide by 2, and you get x equals 5 over 2. So that's how I solve quadratic equations where there's two terms using factorization. So if there are three terms, there's another way that I factorize. I find two numbers that multiply to the constant and add to the number in front of x. So for this first equation here, the two numbers that multiply to 9 and add to 6 are both 3. So I get x plus 3 times x plus 3 equals 0. Null factor law. Either the first bracket or the second bracket equals 0. Both cases, I get x is minus 3. So this is an example of a quadratic that had one solution. So looking like that. So over here, I'm going to find two numbers that multiply to positive 24 and add to negative 11. They are minus 8 and minus 3. So the two solutions to this, if the first bracket equals 0, or the second bracket equals 0. So this one, if I were to graph, has two x-intercepts. So So down here, this one's a bit tricky because of the negatives. I need to find two numbers that multiply to negative 30 and add to negative 7. So those two numbers are minus 10 and positive 3. Minus 10 and positive 3 are not the solutions. The solutions are the opposite of them. X equals 10 if the first bracket equals 0, or minus 3 if the second bracket equals 0. So that's all for factorization. But sometimes I'll get ones like these that I can't factorize. So this method for trinomials, where you find two numbers that multiply to this and add to this, it only works if the number in front of x squared is 1, as it was in all of these cases. Here, the number in front of x squared is not 1. This is a trinomial, but I can't use this method here. So I'm better off using the quadratic formula. So the quadratic formula talks about b's, a's, and c's. A is the number in front of x squared. So here a is 2, b is the number in front of x, so it's 5 in this case, and c is the constant term, so minus 1 in this case. So, what I have here, I calculate the discriminant first, because it will tell me if there are any solutions. So, it's b squared minus 4ac. So, here the discriminant is 5 squared minus 4 times 2 times minus 1. So, putting that on my calculator, the discriminant is actually 33. So, because the discriminant's positive, there will be two solutions. And so the solutions will be x equals minus b plus or minus the square root of the discriminant over 2 times a. So this gives us two solutions. Minus 5 plus the square root of 33 over 4, or minus 5 minus the square root of 33 over 4. So if I put these on my calculator, I get one of the solutions is about 0.186, and the other solution is about minus 2.686. So there are two solutions. Unlike all these ones, I didn't get a whole number. So let's try this one here. So let's calculate the discriminant. So it would be b squared is 9 squared, because b is 9, 81 minus 4 times a times c. Now, if I put that on my calculator, I get minus 31. Here, the discriminant is less than 0, and there would be no solution. So if I tried to graph this parabola, it would look like this one in red. It has no solutions, no x-intercepts. So I know I went through this really quickly because we did it recently, but it's really important we know for graphing. So please let me know if you don't understand anything. All right, thank you so much. This has been the luckiest maths teacher in the world. Have a great day.